Welcome everyone to today's program, CUCM and IP phone security. We're glad to have you with us. A few housekeeping notes to begin. As you entered the WebEx console, you either joined us by audio broadcast or by phone, which was automatically muted. Because of our large audience in attendance today, you will remain muted throughout the event. When you have a question, please feel free to enter it into the WebEx Q&A panel as you think of them. You can find the Q&A panel in the bottom right-hand corner of the console. Please leave the WebEx chat window for communication to our WebEx facilitator for any problems or issues you may be experiencing today. We would also appreciate your input regarding today's webcast. A short survey will appear when you close your browser at the end of the event. At this time, I'd like to pass it over to our moderator, Satish Chandran. Satish?
Thank you, Ria. Hello, everyone, and welcome to the Cisco Support Committee. Today, we present a live Cisco Support Committee Expert Series webcast. During our event today, our topic will be Cisco Unified CallManager and IP phone security. My name is Satish Chandran, and I'm the Business Operations Manager for the Cisco Support Committee here at Cisco. Our experts joining me today is Amit Singh and Raees Shaikh, both customer support engineers based in India with broad experience in voice technologies. Welcome, Amit and Raees.
Hey, thank you, Satish. Thank you, Satish. It's a pleasure to be on this webcast. And we also have with us our technical panel, Chirag, and he's one of our software engineers working with the security team.
Great, thank you. Now I'd like to briefly outline the format for today's Expert Series webcast. Amit and Raees will start with a short presentation on Cisco Unified CallManager and IP phone security for the first 60 minutes of the program, and then we will dive into the live question submissions for the remainder of the event. During our live presentation, you may submit a question to be answered by Amit and Raees and the technical panelist using the Q&A panel on the right-hand side of the console. The team of technical experts is well versed with voice technologies. So please begin posting your questions now to give us the best chance of answering them. And if you experience any technical issues, please post your question in the chat window that is also on the right-hand side of the window. So we'll be asking polling questions during this webcast, and we encourage you to participate by answering them. You may download a PDF copy of today's presentation using the link in the chat window. So now let's get started with today's event. Let's get started with the polling question for the audience. So the question is, what is your level of experience with CUCM or phone security? The options are A, I know basic security, but no idea about CUCM security. B, I theoretically know CUCM security, but no practical experience. And C, I'm playing with it in the lab. And option D, I'm running it in the production. So please take a moment to answer. The poll is open on the right-hand side of the console. Thank you. All right, while you answered that, we'll be reading the results a bit later. So make sure you submit your questions as we'll be answering them later in the webcast. Now I'd like to hand over the mic to Amit and Raees, who will give you an expert look into the topic.
Hi, everyone. So today's agenda is going to be a brief overview of CUCM security. Recently, what we have seen is recently the amount of cases which we get around are majorly being, say, phones not registering after we upgraded the cluster or other phone or certificate issues. So that's the reason we decided that we should try to give a brief overview of CUCM security and how we incorporate or how we implement onto the CUCM or the phones to make everyone aware of the basic terminology. What is the CTL? What is the CAPF? To get familiar with all these jargons or the words or the keywords which we use, so that we have a basic familiarity. We know that we have a CUCM security guide being available, which is like a good source, and most of the information which we are going to present into the presentation comes from there. That's like the Bible for CUCM security for IP phones and for the CUCM itself. So we will just continue with our terminology first. So here's a brief agenda what we're going to cover. So first of all, we will cover some basic terminology, followed by a sneak preview of security fundamental, what is a PKI structure. Then we will go to some new feature which is being introduced, security by default. We are going to cover it a bit in detail. Then we are going to discuss few of the scenarios or the best practices. What we have done here is we have taken some common scenarios which we usually face, or as attack we get cases upon. Then we're going to cover a bit of troubleshooting. So it's not going to be a troubleshooting in detail for this particular session. It's going to be an overview of what all information we can collect or can be looked at while troubleshooting a security issue. Finally, we are going to wrap it up with a summary of all the key points being covered. So now I'll hand over to Raees, and Raees will start with the terminology description.
Hello, everyone. So in terminology, as Amit Singh said, we'll discuss a few keywords that we will be using later on in the slides to discuss the concepts. So we will build upon these keywords and then try and understand the concepts of the new features that we have in Communication Manager 8.6. Starting with public key infrastructure, what is a PKI? I'm sure many people must have heard about PKI. So PKI is actually a framework that is used for encryption, decryption, and authentication by means of a certificate which binds the public key with respective identities. Next, we have CTL file. Now, CTL file is actually created using a CTL client. This file consists of certificates from all the nodes that is signed using the private key from the E token. Phones in 7.x and 6.x cluster use the CTL file for all sorts of security needs in Communication Manager 6.x and 7.x, and even in 8.x for some reasons, which we will be discussing later in the slides. Identity trust list. ITL files were introduced in Communication Manager 8.x onwards. It consists of a minimum list of certificates that are required by the phone for authentication, decryption of the phone configuration file that was encrypted by the TFTP server, and authentication against the TVS service. Now, unlike the CTL file, which consists of certificates for all the nodes it needs to talk to, the ITL file only consists of certain certificates, which it can accommodate in its small memory. Now, the screenshot that we have is the CTL and ITL file from my phone, which you can check even on a 79. This screenshot is from a 7975 phone, but the procedure is mainly the same. You can go to settings, security configuration, and trust list to check the CTL file fingerprint and ITL file fingerprint. Next, we have the CTL client. Now, CTL client is a plugin which you can download from your Communication Manager and install it onto your Windows desktop. The CTL client is used to create a CTL file, which it does by contacting the CTL server, and it will download all the certificates from all the nodes in the cluster and sign it using the private key which it obtains from the E token.
Right, so next comes the CAPF, that's the Cisco Certificate Authority Proxy function. CAPF server primarily runs only on the publisher in the cluster, and its main job is to provide or act as a certificate authority for endpoints. And it issues the locally significant certificates to the endpoint. Coming on to e-token, so as we know, the e-tokens are, if we have to order these e-tokens, we use the keyword or the product code key-ccm-admin-k9, and these e-tokens usually contain the public, like the X509 certificate from the Cisco Certificate Authority, and these are the ones which we use while along with the plugin to encrypt or create a CTL file. Now, one thing I would like to add is we should be keeping them like really in a safe place, or at least have a backup e-token. The reason we say we should have 2 e-tokens is just in case if one is lost, you still have one more. And at any point of time, even if we have one CTL token available or e-token available, you can always use the CTL client, buy a new CTL client, and you can add it to the list so that you have a backup being available.
To add on to what Amit Singh has just said, we require these e-tokens need to be kept in a safe place, because even if you want to move from a mixed mode or a secure mode to a non-secure mode, you will still need the e-token.
Right. So next comes the MIC, or what we know as manufacturer installed certificates. So what we have seen is before a bit of I won't say confusion, but like a lack of clarity between MIC and the LSCs. So MIC, or the manufacturer installed certificates, are the ones which got installed on the phone when they were being manufactured, and they are being like signed by Cisco CA. Main function of these manufacturer installed certificates is to authenticate itself to CAPF service, so that once the authentication is being done, once the phone is being authenticated to the CAPF, CAPF is going to issue a LSC, what is a local significant certificate to the phone. Coming down to locally significant certificate itself, this particular certificate is being required for a secure connection between communication manager and the phone. Now, this certificate will get downloaded only after a successful authentication between MIC and the LSC. And MICs are the one which you can't remove or delete from the phone. So here we come to the security fundamentals, which Raees is going to continue and explain the PKI further.
Yeah, so this presentation is actually under the assumption that the engineers who join know a bit of security. But for the benefit of few individuals who might not have come across the security basics, we will just have an overview of how things work when it comes to security and how authentication and encryption is done. So the first method was symmetric encryption. Now, the user A on the left-hand side wants to transfer data, which is the small briefcase that you see, to the user B on the right-hand side. Now, this data has to travel over public network. Now, anybody in the public network can snip the data and see what is being transferred. So, what user A does is it generates a secret key. And this secret key, it will transfer it to user B over the public network. Now, user A will encrypt its data using the secret key and send it on to user B. So, since user B has the secret key, it will be able to decrypt the information that was sent by user A. Likewise, when user B wants to send data, it will use the same secret key to encrypt the data and send it across to user A. So now the data is being encrypted and it is being transferred over the public network. Since it is encrypted, nobody can actually snip the data and see what is being transferred. But there's a limitation to it. What if the secret key, which is being sent across to the other remote user over public network, is being snipped? Then the man in the middle can actually use that secret key to decrypt all the data and check what information was being communicated across. To overcome this limitation, we came up with the concept of asymmetric encryption. In asymmetric encryption, each user will generate a pair of private key and public key. So the private key is something that it will keep it with itself, whereas the public key will be communicated across the public network to the remote user. One point to note here is that anything that is encrypted using the private key can only be decrypted using the public key. What it means is if you are able to decrypt information using the public key, then that must have encrypted using the private key. So user A generates a pair of private and public key. Likewise, the user B will also generate a pair of its own private and public key, and they will keep the private key secret with themselves and exchange the public key over the public network. Now, using the public key of the remote user, each user will encrypt its data and send it across the public network. Since the user has its own private key, since the user has the public key of the remote user, it will be able to decrypt this information. And as the data is traveling the public network in an encrypted format, nobody will actually be able to sniff the data and extract the information that is being communicated. However, there is a limitation even to asymmetric encryption. How do you know that the public key you received and the communication that you're doing is from a valid user with whom you wanted to establish communication with? To overcome this asymmetric encryption limitation, we came up with something called public key infrastructure. In public key infrastructure, we have a certificate authority which will issue certificate. But even before certificate authority issues certificate, the user has to contact the certificate authority and provide its details like its identity, its public key, and all the other parameters that is required in its certificate. The certificate authority will verify and authenticate if the public key belongs to the proper user, and after the authentication is successful, it will sign the certificate with its own private key and put a signature on the certificate and issue that certificate to the users. Now both the users have the certificate authorized by a central certificate authority, and they will this certificate consists of its identity and the public key. They will exchange the certificate over the public network. Now, since they have the public key of the remote user, they will encrypt their data with the public key of that particular user with whom they want to establish communication and exchange the encrypted data over public network. The user will use its private key, which it kept with itself, to decrypt the data and generate the information and extract all the information that was communicated from the remote user. So this is a small summary of how PKI and security actually works in today's environment.
Thanks, Raees, for setting up that base for our further discussion. So right now we're going to discuss about phone security in pre-8.0 CUCM servers, which essentially are like 4.x, 5.x, 6.x, and 7.x CUCM clusters. So before, if we have to secure a cluster, other than the authentication and the encryption purpose, we have to run the CTL files. And all the trusted certificates, as Raees explained before, we use the CTL client to bundle all the certificates in a CTL file, and that CTL file was being downloaded by the phones. But I think we have really progressed a lot further in our technology, as well as the way our phones can operate. Now you can run a lot of midlets on our phone. You can do internet browsing on your phone. You can run many applications over the phone. Now, most of these applications, they may be on internet. So what brings along, is the need of security. And when security comes in, okay, there are certificates. But our phones, they are limited by the amount of memory or the resources they can have. So say, for example, I have to trust a lot of applications or a lot of certificates, then my CTL file size is going to grow big because my phone has to trust a lot of certificates now. So in this case, my phone will be limited by the limited memory it has. So that was one of the scalability issue with the CTL which we had. Then coming down to the flexible part, every time we have to generate a new certificate, we have to remove a certificate, the file that we have to rerun the CTL client every time. The CTL client needs to be run because it's going to like after we rebuild the file, then CTL client needs to be run. We need to restart TFTP services so the TFTP server is aware of the CTL file. Then we have to reset the phones so that the CTL file is being downloaded. So those were the two major issues we encountered, and we try to fix it in our coming future releases. So here we have something which Raees is going to talk about, the newer security by default.
So coming down to the security by default, first I would like to discuss why security, because this why question is always more important than how and what. Why we need security when we are communicating using IP phones in CallManager. For example, enterprises like bank or stock exchange or even military organization, they want their signaling and the media and whatever authentication they have, they want to make sure that there are no attacks or vulnerabilities left in their environment of communication. They want secure communication occurring between their endpoints, their servers, and between two IP phones as well. So why we came up with this security by default? The reason Cisco came up with this feature is because we believe that apart even from the bigger enterprises to even smaller enterprises in today's world, they need secure communication. They need some sort of security in their enterprise. So that is why we have come up with this concept, which is called security by default, which means security is by default available in your once you install or upgrade your CallManager to 8.x version and above. What this feature allows is default authentication of TFTP downloaded configuration files. So whatever configuration file an IP phone receives from the TFTP server, the phone will check whether it received it from a valid TFTP server or not. Optional encryption of TFTP configuration file. Now this feature is optional, and what it does is it will encrypt the configuration file so that nobody can sniff the configuration file and see the contents of that file. Also, we have a new feature called Trust Verification Service, and the phone will have the certificate installed in its file called ITL file to communicate with the TVS service. Now, these are the phone models that support security by default, and older models like the 7905, 7912 do not support security by default, but then the communication manager will provide them with a configuration file which is not signed, so that these phones will still work with communication manager version 8.x and above.
Right, and to add, what we can do is the best way, or if you would like to say, okay, what phones are supported, the CallManager versions which have unified reporting in them, you can always run a unified report for the phone feature, and that will show you a list of phones which support security or any kind of feature.
Thanks, Amit. So coming down to ITL file. Why ITL file? Now, compared to CTL, there were some limitations and challenges which Amit discussed. So compared to a CTL file, ITL file is leaner and smaller, which means that it only consists of a minimum list of certificates like the TFTP or CallManager certificate, the TVS certificate to authenticate against the TVS service of CallManager, and the CAPF certificate in case it needs to download the LSC certificates. Unlike the CTL, the ITL file is automatically generated once you install the CallManager and start the TFTP service. There is no need for hardware e-tokens because it uses a soft e-token which is already present in the call manager. The newer firmwares of the phone will actually ask for a CTL, as well as it will ask for an ITL file, which we will see in the next slide. So this is a sniffer output from one of my phones. I upgraded my communication manager from 7.x to 8.x. The first thing that the phone will do is upgrade its firmware, because on 7.x maybe it was running, for example, 8.5.2. Once the communication manager got upgraded to 8.x, it delivered the phone with a higher version firmware. In my case, it was 9.2.3s load. So the first thing phone will do is upgrade its firmware, and it will reset itself. After it boots up with the new firmware, based on the logic in that firmware, it will first ask for a CTL file, right? But my communication manager 7.x was not running any sort of security, so there was no CTL in it. So the TFTP returned a file not found error. Next, the phone will request for an ITL file. The ITL file was automatically generated when we moved to communication manager version 8.x and performed a reboot of the server. So the TFTP server will deliver the phone with its ITL file. It will consist of the communication manager certificate, the CAPF certificate, and the TVS certificate to authenticate. Now, once the phone receives the ITL file, it will request for a signed configuration file. In communication manager 7.x, it used to request for SEP MAC-address.cnf.xml, whereas in communication manager 8.x, it will request for SEP MAC-address.cnf.xml.sgn, which will be delivered by the TFTP server. Now, how does the TFTP actually generate the signed configuration file? What it does is it will take the configuration file sep.cnf.xml, and it will run through a hash algorithm, either MD5 or SHA-1, and it will generate a hash output for that configuration file. This hash output will be signed using the TFTP private key to form the signature, and it will attach the signature to the configuration file and deliver it to the phone. Once the phone receives the configuration file, it has to now verify if the signature is from the proper TFTP server it wants to communicate with. In the ITL file, it will already have the certificate of the TFTP server and its public key. So once the phone receives this file, it will separate the configuration file and the signature. So the signature, since the phone already has the public key, it will use the public key to decrypt the signature and get the hash output. Also, simultaneously, it will put that configuration file through the same hash algorithm and generate the hash output. And now, if both the hash output match each other, which means that the verification is a success, and it will install the configuration file and move on with contacting the communication manager for its registration. We have a question from where phone will get the new firmware. The phone will get the new firmware from the TFTP server itself. So first, the phone will boot up as SEP. Once the phone boots up and contacts the communication manager, the TFTP server will give it a non-signed configuration file, which is .cnf.xml, which has information about the new firmware. The phone will compare its firmware and the firmware that it received in the configuration file. Since the one in the configuration file is of higher version, it will contact the TFTP server to receive that higher version firmware and install it.
Thanks, Raees. I think that was that really explained pretty well how the phone verifies the configuration file and how exactly the ITL file works. Now we'll cover the TVS. So this is the new service which is being introduced in the Call Manager 8.x and above, so that we can take the load off from the phone or the resources being consumed on the phone. So the TVS service, it gets installed, and the TVS certificate gets generated automatically when we install this UCM cluster. Coming on to the scalability part, at this point of time, phone resources are not impacted by the number of certificates to trust. Reason being, we're downloading the ITL files. Now in ITL files, whenever a phone is being presented with a certificate that it has to trust, it will check in its ITL file. Okay, do I have it in my certificate or not, in my list or not? If it doesn't have that certificate, it will contact the TVS server, and the TVS server is going to look up into the trust store. I'll explain a bit later on the trust store part. So at this point of time, TVS server will look up, okay, is this certificate present in my trust store or not? If it is there, it will say to the phone, okay, go ahead and trust this application or the certificate which is being presented to you. Now, the flexibility part. Unlike CTL, where we always had to rerun the CTL client every time we did an addition or deletion of the certificate, that's not the case here. So every time we do any kind of certificate upload or removal, that is automatically reflected in the system. So whenever we have a service called change notification, certificate change notification, so whenever we face any change being done to the certificate or being added or removed or uploaded, TVS will be notified, and then later on it will notify the TFTP, like say in CUCM 8.6 and above, TFTP server is the one responsible to build and sign the ITL files. Right. And
one thing to note here is that we still need the CTL file or the CTL client in case you want to encrypt your communication, like signaling and media. Now, using ITL, we can authenticate, but if you want to go a step ahead in terms of features and encrypt your signaling and media or the RTP stream, you will still need CTL in Communication Manager 8.x.
Right, now the question comes, okay, how do I know, or how the phone knows, okay, like who is my TVS server and whom should I contact or talk to? So as we know, the TVS server names or the IP addresses will be same as of your CM group, which is being assigned to the phone. So the way we have like a primary, secondary, and a tertiary call manager, same way we are going to have a primary, secondary, and tertiary TVS service also. So what happens, like if one of the TVS goes down, one of the server goes down, phone will try to contact it. If it's not able to set up a connection with the TVS, it will try the second server, and afterwards the third server if the second not available. Given the condition, okay, the ITL file is same on all the servers, so any of the TVS server at any point can authenticate the certificate for the phone.
One thing to note here is, again, the TVS runs on port 2445, so you need to have this port open in your security firewall and in your setup, basically. So instead of downloading all the certificates and forming a huge CTL file, what the ITL will do is for any certificate that it does not have in its ITL file, it will contact the TVS service on port 2445. Now that certificate needs to be initially installed in the trust store of CallManager. And TVS is, every time you start the CallManager service, like you have a fresh install and you activate CallManager, the TVS service is also activated. So the phone will contact the TVS service, and it will authenticate and move on and ask the phone to trust that and move on with the rest of the things.
Right. So here we come to a bigger picture, and this diagram is just to elaborate how do we go about, or how does the phone think, okay? So it's just more of a visual representation of what we just explained before. So for example, we have a CTL file and the ITL file on the phone. Now, phone tries to contact a midlet server. So midlet server, application server, is going to present the phone with a certificate. Now, phone is going to look into its CTL and ITL file, okay, if I have the certificate or not. So as you can see here at this point of time, signaling, okay, uses the CTL file. And if you look at the third yellow box, that says HTTPS, so that will use the ITL file. So in this case, phone is going to request, phone looks up, okay, I don't have the certificate, so it will send out a request to the CUCM, or we can say in our case, our TVS server. In the background, TVS server is going to look into the trust store and see, okay, if I have this certificate in my repository or not, and do I trust it or not. TVS looks up, finds, okay, yes, you're good for authentication, go ahead and talk further. So the TVS server will respond back, you're okay to communicate with this application who has presented you with this particular certificate. And that's how we reduce the load on the phone by not keeping the bigger ITL file there.
One thing I would like to mention is you just have to upload the third-party certificate that you want to trust on the publisher or on one node of your cluster, right? And that certificate will be replicated based on DB replication to all the other servers in the cluster. And there is a change notification mechanism. Once we receive the new certificate in the repository, the change notification is going to inform the TVS service about it.
Right. So I think one quick question, okay, is you really don't need to have a internet connection available in your system. So once you have the certificates being installed, what I mean is, say I want to go for a specific application. It can be in-house or it can be something hosted on the internet. Now I'm going to have a certificate from that particular certificate authority given to me. I'm going to install that certificate in my trust store on the CallManager. That way I don't have to go out all the way back to the certificate authority to identify that certificate, because I already have a root CA or a root certificate on my CallManager to identify.
Okay, so before we get back to the presentation, I'd like to take a moment to ask another polling question. The question is, what advanced CUCM topic are you interested in future webcast? Option A, follow-up session having live demo of CUCM security and troubleshooting. Option B, Cisco extension mobility cross-cluster. Option C, CUCM troubleshooting and trace reading. Please take a moment. The poll is open on the right-hand side of the window. Thank you.
Now, coming down to the troubleshooting section. In this section, we're going to discuss about what information is required, to troubleshoot any TVS issues or, phones not trusting a particular certificate. So what logs that the customer needs to provide tag, or what you can do to resolve this issue. Mainly, we need, if, for example, the phone is not trusting a particular certificate, right, and some services are not working in your phone, which uses HTTPS connectivity. So in that case, you need to set the TVS service log to detailed mode and restart the TVS service, reproduce this issue, and collect the TVS logs from RTMT, the show ITL and show CTL output, and the phone console logs. You can gather the phone console logs from, typing in the IP address of the phone into your web browser and going to console log to the left-hand side of the web page. The show ITL and show CTL output will be given in the CLI. You can go to the CLI of your communication manager and give the command show ITL and show CTL, note it down, copy it down in a notepad file, and send it across. Also, we need all the console logs from the phone.
Right, and just to add, show ITL and show CTL file commands, they're like really useful commands, and you can always run on your SSH access to the server to verify if it's a valid file or not. Because at the bottom of the output of show ITL or show CTL, it does give you an output, okay, if this file is valid or not. So if you see that the output is not valid, or it says the certificate or the file is not valid, then definitely okay, we have an issue. So that's one quick way to identify.
Moving on, we will also, along with the information that we discussed in the previous slide, we will also need the configuration file, which you can download either using services like FreeFTPD or the TFTP service from your desktop. Also, if the issue is with a specific certificate, for example, many services are running, but you have added another certificate to the trust store, but the phones are unable to authenticate it. So in that case, along with the CTL logs, we will also need the TVS logs. We will also need the certificate management logs, which you can set to detail from the communication manager serviceability page, and the change notification logs. As we discussed before, once we add the new certificate to the server, it will, via DB replication, it will replicate the certificate to all the other nodes in the cluster. And the change notification will inform the TVS service about the new certificate that needs to be trusted. So if that is not working, we definitely need the certificate management logs and the change notification logs.
Right, and I would like to add one thing here, and I think, like most probably it might be a misconception, okay, or maybe we're not aware of it. That's how the configuration files are being stored on the server. So most of the time, the conception is that the configuration files, okay, they will be stored on the TFTP and you can get them from there. But actually what happens, okay, these configuration files, they are being generated on the fly. What I mean is, whenever a phone or like say, even if you will execute this TFTP command saying, okay, I want to request this SEP MAC address.cnf.xml file, TFTP server is going to generate that file on the fly, okay, considering, look into the database that, okay, what all parameters or what all settings are being configured for this phone, and then it will just put all this information in an XML file and send it across to the phone. Right, so right now we're going to cover the some of the common issues and what are the most probable remedies we can use to come over these issues. So one of the things which we might have seen is, okay, I moved my phones to another cluster and it doesn't register. So there are a few steps which we have to take before, and there are some steps which we can take later on as well. So the most popular parameter, and I think the most useful in the newer scenarios, is the rollback enterprise parameter. So if you go to your system menu, okay, then you can have this enterprise parameter, prepare cluster for rollback to pre-8.0. By default, it's being set to false. And once you enable this feature, what you have to do is you have to reset the service, you have to reset the phones. In the background, what it will do is it's going to create a ITL file. And in that ITL file, the TVS and the TFTP certificate sections will be empty. So even though the certificates are there, but they will be empty, they will not have any signature. That will make the phone to accept any unsigned configuration file. So this thing needs to be done before you are moving your cluster or your phones to a different cluster, which will have a different set of ITL files. So the moment you say on one cluster A, you set this parameter, phones download the empty ITL files with empty TVS and TFTP certificate sections. The moment you point those phones to cluster B, which has a different set of certificates or ITL files, the phone will simply download the new ITL file. It will believe it, and it will trust it, and it will download it, and for the further or the future changes, it's going to keep using that same ITL file. Second method which we have, okay, is when we have connectivity between the two clusters. In this case, we have bulk. We can migrate the certificates from one cluster to the another cluster. So, and then the ITL file will be regenerated on the migrated cluster. And over there, we can, as the ITL file will have the entries of the new certificates from the old cluster, it will trust and it will believe okay, that okay, it is a cluster or the server to which I can authenticate to and I can trust, then the phones will register. Right. Now, the most popular method, which works without a fail, like unless we lose the certificates or we, the certificate tokens, okay, e-tokens, they are corrupted. So, simplest way, if you had a cluster which was being secured by running a CTL client, the only thing you have to do is you just have to move the phones, run the CTL client again, phones will download the CTL file, and we are good to go. Now here comes the most horror part, we can say, okay, or the most difficult part. Say if the things go bad, okay, or we catastrophic changes. Say for example, we deleted both the CUCM and the TFTP certificates in this cluster, or so that the ITL files can't be regenerated and downloaded again. In that case, we will have to go for a manual deletion of the ITL files. Now,
yeah, one thing I would like to mention here is that never regenerate or delete your CCM or TFTP, which is the CCM and the TFTP certificates are the same certificates, callmanager.pem or callmanager.der. And so what I mean is never regenerate your callmanager.pem certificate and your TVS certificate at the same time. So what will happen is once the phone receives the new ITL file, it will look into its ITL file and try to authenticate it. If the certificate does not exist, it will try to authenticate against the TVS service first to check with the TVS service will be able to authenticate. But since it's a new TVS certificate as well, the TVS connectivity between the phone and the communication manager will be refused. So the only option at that point in time which will be left is like manually delete the ITL file, which I'm sure most of you all don't want to go ahead with it. We have a question. Is it possible to SSH into phone and check for security problems? Well, it depends on the problem, but it depends. If the problem is with the phone, then we can, the phone view will actually give us a set of debug commands that we can run into the phone and see if it is why it is not able to download the ITL file or why it is not able to trust the certificate, even though the TVS service is asking the phone to authenticate and to trust the certificate. So in such scenarios, we can definitely SSH into the phones and run some debugs and see what is happening. But that is not a normal condition. So again, we have certain issues. We hear a lot of time that you move to 8.5 and for some reason you have to go back to 7.x or 6.x communication manager version. And once you move from 8.x to 7.x or 6.x, the phones are not able to register. This is a common problem that we have received, and the reason is because the phone 7 ITL files. So once you move back to communication manager 7.x, for example, the phones will not be able to authenticate the configuration file that it received from the TFTP server in 7.x cluster. Hence, it will not accept any new configuration file and it will not register to call manager. Now, in order to overcome this, what you need to first do before you move on from 8.x to 7.x, you need to use the option prepare cluster for rollback to pre-8.0 from enterprise parameters. Set it to true so that it downloads the empty ITL file and then restart the TVS, TFTP and the call manager service. The reason because once you restart the TFTP service, it will generate the new ITL file and restart of call manager service is required so that the phones reset and are able to download the new ITL files. You can then go ahead with the downgrade of the server once they have the empty ITL file in them.
Right, and so going forward, what we have seen is, okay, I have regenerated my CAPF, TVS, or CUCM certificate, and now my phones don't register. So at this point of time, if any of the CAPF, TFTP, or TVS certificate is generated, the ITL file needs to be updated on the phones. And as you can see, we have the procedure here. So restart the CAPF only if the CAPF certificate was regenerated. In ideal scenarios, if we are not regenerating the CAPF certificate, there is no need to restart the CAPF service. We need to definitely restart the TFTP. The reason being, it has to refresh its cache with the new ITL file so that the phones can download. We can do a reset of the phones or a restart of CUCM service on all the nodes to force phones to download the new ITL file. And I'm sure that we will be carrying out these procedures in a maintenance window when we know, because these are some changes which we don't do on fly, and we definitely know that, okay, this is a time frame or this is my maintenance window when I'm going to regenerate my certificates. So proper care, like in arranging a maintenance or a downtime window, is very much required. And again, as we say, TVS does not need to be restarted as well, and no user intervention is required to rebuild the ITL file. Reason being, due to the certificate change notification service, whenever there are any changes which are being done to the certificate, the TVS is being automatically notified and the ITL is being regenerated. And
we have a question: which two certificates we shouldn't be regenerating at the same time? It's the call manager or the TFTP certificate and the TVS certificate. Never restart or regenerate both the certificates at the same time.
Right. So the CUCM certificate, okay, it's the same as TFTP certificate, and we use the same as to sign the same private keys being used to sign the any kind of authentication or the signature further. So that's why the CUCM and TFTP certificate is same. So as Raees mentioned, we should not try to generate both the CUCM or the TFTP plus the TVS certificate at the same time. Now, as a precaution, if you plan to regenerate multiple certificates, okay, first definitely you need to have a downtime or a maintenance window, just in case there is something unexpected. Second, regenerate the TFTP certificate in the end. That should be the last certificate you should be regenerating. And definitely, by rule of thumb, whenever the TFTP certificate gets regenerated, you should definitely take a new system backup. With going forward with CUCM 8.x and above, the TFTP certificates and the private keys, they're also being backed up, and not to worry about, it's all secure. Like you might be thinking that my certificate is going out or my key is going out. It's all secured, it's all encrypted, and it's not available outside.
So now you have CallManager 7.x in secure mode, and you want to upgrade it to 8.x. And once you upgrade your communication manager to 8.x and then you restart the call manager, the phones are unable to register. Now, this is one of the most common issues that we face, we've heard about from the customer. So what you need to do is just rerun the CTL client and update the CTL file and then restart the TFTP service. Okay, so once you move to 8.x and running the CTL client, it will download the latest call manager certificate and the TFTP certificate from a CTL file, and after restarting the TFTP and call manager service, it will push that CTL file onto the phone so that they can trust them. Auto registration. Will auto registration work with security by default in call manager 8.x? Yes. The auto registration will work with security by default, but the default configuration file that will be given is a signed file, because the phones first request for an ITL file and then for a configuration file. And a few phone models, the older phone models that do not support security by default, will be given a non-signed default configuration file. However, please note that auto registration will not be supported in mixed mode. What I mean by mixed mode is that you have a call manager 7.x and which is in secure mode by running the CTL client. But even after running the CTL client, you have the option of having some phones in secure mode and other phones in non-secure communication. For example, you want the communication between the CTO and the CEO to be secure. So you can assign these phones with a security profile that has security enabled. But for example, if you don't want a lobby phone to be secure, you can assign a non-secure security profile to that particular phone. So right now in your cluster, you have both secure communication with some phones and a non-secure communication used by the other phones, and that is why we call it a mixed mode.
Right, so the only two modes which we have are non-secure and the mixed mode.
So what happens if you have to re-image your server? One thing that you can do is, even before you actually go ahead and re-image your server, it will be nice if you use the prepare cluster for rollback parameter and deliver the empty ITL file to the phones by restarting TFTP and CallManager service, and then go ahead with the re-image of the server. So any new ITL file that will be downloaded by the phone, it will accept it and install it. However, if this parameter was not set, then the only option that will be left once you re-image is that since it has new CallManager and new TVS certificates, the only option left will be to manually delete the ITL files from every phone.
Right. So you might ask a question, like say if I have a DRS backup, why can't I kind of simply restore my DRS backup when I'm going to re-image my server? That's very true. You can, if you have to rebuild the server, if you have the latest backup, and you haven't regenerated your certificates after taking the backup. So that means if you have a valid backup with all the new servers, with all the new keys, the TFTP key, the latest backup after you have regenerated your certificate, then definitely you can go ahead and restore your backup. But in real world, like we can be into some situations, or what we have seen out of experience, that sometimes we don't have a readily available DRS backup. And we run into some situations that we have to re-image the server. So what we have to do is we can have a last attempt of setting this parameter and see if the phones can download the the empty ITL files. And I think this will be more of a peculiar situation where, like, say you have only one server in the cluster. Because if we had multiple servers, phones can even if you re-image one of the servers or one of the TVS servers, the phone can always go to the remaining servers for the authentication purpose. So this will be like a peculiar situation which we wanted to cover. Say you have a single server in cluster and you have to go for a rebuild. So this is something, the prepare cluster for rollback is something which you can try, so that you don't have to delete the ITL files on every phone manually. Right, so here we come to the summary of our presentation. We'll cover a few points and again reiterate on a few of the points. CUCMA.X and above, they have security by default enabled. That means whenever you upgrade or install a new version, it's a new install or a upgrade, it is going to have security by default enabled on it. If you want to have secure media and encryption, then you need to run the CTL client. TVS, or the Trust Verification Service, is something which is new, and I think most of us may not be aware of it. So this session was mainly designed to give us a new prospect of what we are coming up with. So TVS is a new service introduced, and it is going to continue as far in our future releases as well. Whenever we plan to move our cluster to 8.x, install or upgrade, please make sure we have the TVS port 2445 and TLS protocol allowed in your network, just in case if you have a highly secure network. Because if these ports are blocked, phones will not be able to contact the TVS servers, and in result, they will fail to download the ITL files and they won't be able to register. As again mentioned previously, auto registration will still not be supported in mixed mode. Auto registration is only supported when we are running in non-secure mode. And once
auto registration, as I discussed before, is also supported in security by default feature, which means that if you move to CallManager 8.x and you have prior to moving you were not into a secure or a mixed mode, then you don't have to worry. Auto registration will still work with security by default.
Right, and next one is the mystery of rollback enterprise parameter. What exactly it's doing in the background? By default, it's being set to false in any cluster. The moment you set it to true, the phone's an empty ITL file will be generated, which will have empty TVS and the TFTP sections. By the phone firmware is being designed in such a way that if these sections are empty, it's going to download or it's going to trust the ITL file which will be given to it. And again, the most important part, or very important part, anytime we regenerate TFTP certificates, do take a DRS backup, because that saves you a lot of trouble and a lot of time later, and a lot of effort in like a later point of time. And anyways, like DRS backup is always being recommended to take. And what you can do is in 8.x and above, okay, TFTP certificates, and as we mentioned, the TFTP keys, they are being backed up as well. And for the supported Cisco Unified IP phones, not only the security features which are being supported, you can just go ahead and run a unified reporting, and you can select the phone feature option. It will give you a list what phone model supports what feature. Right, and so right now we're going to discuss like some of the future release enhancements, okay, which you might like, which are on the roadmap. On most of them which are already being released. So one famous one, okay, which is being deployed by some huge enterprises are single sign-on. So I'll give you a brief introduction. You can read more about it on our CCO website. So single sign-on is, say for example, you have multiple applications running in your environment, or so the moment you log, or say you use IMAP connections or Unity connection, you use CCM user page and many more applications which connect to via different APIs to the call manager or any of Unity connection or unified applications. The moment you log in to your desktop or laptop using RSA token or your Windows sign-on, you will not have to log in again at all to any of those applications. So that's like a seamless access. Second point is the PKCS 7 chain upload. Most of the CAs nowadays, they give you a chain certificate or a certificate chain. In previous scenarios, what we had to do is we had to request for individual root certificate or the CSR signed certificate to be given separately so that we can upload them using the OS administration GUI page and the certificate page. But given the enhancement, okay, we are going to come up, you can upload a chain directly to the CUCM GUI page on the OS admin, and the certificate service in the background will do the work by itself to separate the root certificate and the and your actually signed certificate, which we got from the certificate authority.
The other feature that we have in upcoming Communication Manager, which is Communication Manager version 9.5, is that there will be an option available in the Call Manager web page that can be used to delete ITL files from all the phones. Right now, the only way is to manually delete it, but we are coming up with an option so that you can delete it from the Communication Manager web page. So these are some of the reference documents that you can refer for more information on this topic.
Right, so we have very good documents being written by Cisco TAC engineers, and like which give you like very precise information about like a detailed process. Okay, so we decided not to indulge into a lot of details on this particular session. We wanted to give a brief overview and what Cisco is doing from the Cisco like security perspective on the CUCM and the phones. please do refer to the CUCM security guide. That's like the Bible, and we have taken all the piece of information, whatever information we have in slide, it comes from our security guide. It's like all well section, and you can get all the information there. And do refer to the documents which we have mentioned here.
We have a question here in which the call manager customer has problem with CTL and ITL files. Without jumping too much into the problem, if the call manager had upgraded to 8.x and then moved down to 7.1, I'm not sure if CTL was running in that cluster, but if, under the assumption that CTL was not running, he moved to 8.x and then he wants to move to 7.x, all he has to do is set that parameter for rollback so that the phones download the empty ITL files. And once you move to 7.x, it will accept the other configuration file that 7.x server is going to provide.
Right. I think we have like one more interesting question. What are the ports that needs to be open? So for TVS to work, we need 2445 port to be open. And if you have any other applications, you can always look up the CUCM documentation guide, which talks about the important ports which needs to be open for different protocols and the functionality.
There's one more question which says, are there any drawbacks to using rollback parameter? I would say no. The only time that you would want to use it is that you're moving from one version to another or from one cluster to another, so that the phones download the empty ITL files and are able to register. Once they register, you need to change this parameter to false and restart your TFTP and your call manager service, so that they download ITL files with exact certificates.
Right. So it's kind of a trade-off. So if you wish, like you want to, see, phones will register even if it's an empty ITL file. The only thing it's not doing is the authentication part. It's just believing everyone by default, because there is nothing, like if the phone is being told not to trust, it doesn't have any certificates. So you can continue to run it. But again, we suggest, like, once your purpose is done with the rollback feature or the conditions, you can always set this parameter back to false, so that the phones can download a fully loaded or a populated TVS or an ITL file, and then then in that case your environment or the phones, they are like authenticating and encrypting as you desire.
All right, so before we start with the Q&A, let's go to our last polling question. The question is, how useful was this presentation? Option A, this was very informative presentation and will help me in understanding security in CUCM 8.0+. Option B, this presentation needed more in-depth details. Option C, I wanted to see some more information on configuration. And option D, this presentation was somewhat useful. Please take a moment to answer. The poll is open on the right-hand side. And so thank you, Amit and Raees, for a great presentation. Also, thank you everyone for participating in the event polling. We'll wait for 1 more minute to see the polling result. Now, I'd like to, this is time to answer some of the questions our viewers have submitted today, and some of them already been answered by Raees and Amit verbally. And if you can't stay for the Q&A session, please be sure to click on the evaluation link provided in the chat to let us know how this session met your business needs and expectations. So let's wait for the polling results here. And while we wait, also the first 5 listeners to complete the evaluation survey will receive a $20 gift card. To complete the evaluation, please click on the link provided in the chat window. That's on the right-hand side.
So we have a question here, and it says, I'm upgrading a communication manager 7.1.5 from mixed, which is already in a mixed mode, to 8.6, and also replacing the server. What we would suggest is, on the current physical server, upgrade it to 8.6 and run the CTL client using the same e-tokens. Once the upgrade is successful and the phones are able to register, take a backup of this and then move to the virtual environment. There, you won't have to rerun the CTL client because the DRS backup will already include the TFTP certificate.
That's right, and we need to make sure that we do a copy, or we do keep the number of nodes same. Ideally, that's what's being desired. So when you rerun the CTL client, like after the upgrade, so when you're on 7.x, make sure like when you move to the 8.x, you have the same similar number of nodes at that point of time.
So there is one question which I'm not sure if it was answered, but do UC applications such as Cisco Jabber for iPhone use ITL file?
I'm sure every endpoint which is by Cisco will support ITL file, but we can check that and answer to our RC Expert forum later on.
Okay. So there's one more question. Are the security features available for third-party phones?
No, right now it is only supported on Cisco phones, not on third-party phones. This feature is only available for Cisco phones.
Okay, there is one more question. I think that's more related to the PDF download from support forums, the slides that can be downloaded. So just to let the users, if you open that document 23637, there is an attachment and that's a PDF copy of the presentation. So you have to just download that. All right, so I see one more question. It says, is the CTL file size limited, and how many modes can I implement within the CTL file?
Well, the CTL file needs to have certificate from all the nodes in the cluster. The file size is not limited, but the memory of the phone is limited. So that is why we have to be careful in which certificate it needs to have in the CTL file.
Okay, thank you. So there's another question. The question is, what is mixed mode cluster?
Okay, as I answered before, you run CTL client and you get your cluster into mixed mode, right? And you have CTL already on the TFTP server. But to make to have secure communication, you can decide. For example, you have your CEO and your CTO talking over the phone, and you want these phones to speak, have encryption on their RTP stream and speak securely, right? Nobody should be able to sniff the data. But on the other end, you don't want so much high security on your lobby phones. So using phone security profile, you can enable security on the phones for your CEO and your CTO. And they will, when they will speak securely. That is, their RTP stream will be encrypted. Whereas the lobby phone, you can use the non-secure security profile, and that phone will just work like any other normal mode. So right now you have few phones which are having security enabled and few phones which are non-secure, right? And that is why we call it a mixed mode.
Thank you, Raees. There's another question that is, what is phone hardening?
Right, so I'll take that one. Phone hardening is essentially disabling some of the features on the phone. What I mean by that is, say for example, disabling the web access. If you disable the web access, most of the scripts, so you won't be able to connect to the phone using HTTP or HTTPS in that case. So in some of the cases, I would like to disable those websites. Disabling the PC voice VLAN access settings. Disabling the settings access settings. What that means is I don't want my end users to change any parameter on the phone, or like make any kind of changes at all to the phone, because sometimes it can be a nightmare, or you might get some unwanted tickets or calls, where the users have access to the phone settings and they did something which definitely won't come to your notice unless you are going to go and look at the phone or investigate further. Another point is disabling the PC port setting. So that's something which, if you're not using the daisy chain mechanism, you're not connecting a PC at the back of your phone if there is no need. So let's go ahead and disable it. And all these things you can do by just going to the device for which you want to do it, and go to the phone, and you can make all the changes. If you have to do it for a number of phones, like more than like 5, 6, 10 phones, definitely you can use the bulk administration tool or BAT to do that.
Okay, thank you, Amit. Let me take one more question here. How do we know a certificate has or is about to expire?
Right. So in our CallManager, if you go to the OS admin page, we have a service called, we have a feature called Certificate Monitor, where you can define when to start giving the alarm whenever a certificate is about to reach its certificate expiry. And it will also, you can also define the frequency of the alarms, when it can be like how many times you want to generate the alarm. Right. So by default, the certificate monitor will send out the alarms to the RTMT. So you can always monitor your RTMT for the alerts, and before 1 month. Okay, and like for a 1 month period, like it's going to expire, it's going to generate the alerts. You can always watch your RTMT for the alerts. And if you want them to be sent out to a specific email alias or an email address, you need to configure the SMTP address. And again, this feature is available on the same OS administration page UI under the security option, Certificate Monitor.
Okay, so we have time to take one last question. So what if I want to migrate only a set of phones to a new cluster?
Okay, you can still go ahead with the option of rollback, and download empty ITL files onto your phones. Once you move those few phones to a different cluster, you can then set the rollback parameters again to false and restart your TFTP and CallManager service so that the phones download the ITL files with the certificates of CallManager, TFTP, TVS, and CAPF. Please do fill out the evaluation survey, because we are in Cisco, we definitely look forward to listening to our customers. So any feedback or anything that you need, training in future, please do let us know. We are listening to you guys.
Yes, and definitely it's going to help us to design, like say, what's the requirement. Okay, if you really want to have a continuing session with more troubleshooting involved, where we can show you, say, RTMT, how to check those alerts, how to collect those traces, and maybe we can go to one more level where we can actually show, okay, these are the key points you can always look up into the certificate. So sometimes, at your end, out of curiosity, you might want to check those logs. Okay, what exactly is happening? It's not only the tag engineer looking into those logs. So we can have that kind of session as well as part of the continuation of this particular session.
Okay. So we have 2 more questions came up.
Yeah.
So
how do we obtain the e-tokens? I think you need to contact the account manager, who will be able to provide you more information on how you can
I think
the e-tokens.
Right. One of the key points which you mentioned before, we mentioned the product ID of the key-CCM admin. Okay, and
it's there in the slides. If you can, refer the slides after this session, and you can contact your account manager with that key ID, and he should be able to help you get the e-tokens.
All right. So that concludes the Q&A portion for today's event. Amit and Raees will be hosting an RC Expert event starting today, that is April 3rd, until April 13th, Friday. If you have additional questions, log on to Cisco Support Committee and click on the Experts Corner tab at the top. Amit and Raees will continue answering your questions through the community site over the next 2 weeks. If you haven't explored the Cisco Support Committee yet, take a moment to check out this excellent resource at supportforums.cisco.com. We invite you to attend our next CSE Expert Series webcast with Jazif Frahim, a double CCI from RTP. The topic will be Cisco Smart Call Collector and New Mobile Clients. It will happen on Tuesday, May 8th at 8 a.m. San Francisco, which is 5 p.m. Brussels time. The registration URL will be available soon in the CSE homepage. Would like to also inform you about our first webcast in Russian with double CCI and RNS and service provider Igor Tumkin. The topic will be troubleshooting common problems of Layer 3 VPN multi-protocol label switching networks. And it will take place on Tuesday, April 17th at 12 p.m. Moscow time, which is 10 a.m. Brussels time. The registration URL will be pasted in the chat window. And we'd like to also inform you about our upcoming Ask the Expert event in English with Pete and Jim starting April 9th. The topic will be Cisco Prime Network Registrar. You may join the discussion at Expert Corner community, which is in the Cisco support community. Another upcoming Ask the Expert event in English with Matt starting April 9th. The topic will be Cisco Hosted Collaboration Solution. And for that also, you can visit the Expert Corner community in the Cisco support community. So we invite you to ask questions and collaborate in the Cisco support community via various social media channels like Facebook, YouTube, Twitter. So feel free to check out that. And if you speak Polish, Russian, Japanese, Portuguese, or Spanish, we invite you to ask your questions and collaborate in your language. The links are provided in the chat, also in the slide. Before signing off, please take a few minutes to complete your evaluation of today's session. This will help us address your business needs and interests in the future. Thank you very much, Amit and Raees, and the technical panelist, Chirag, for sharing your expertise with us today. Thank you and have a great day. Bye.